Let's do the last of the bending moment diagram examples. And what we're going to do is we're trying to find a bending moment, a maximum bending moment for a system like this. So what we have is we have a simply supported beam. It's got a 60 kilonewton weight at 3 meters, and then it's got a UDL, a uniformly distributed load. So what's that mean? Well, the UDL would be something like a bar of iron or something like that, which means that it's homogeneous, it's the same all the way along, and that means each little bit adds the same. So this could be like a concrete slab, but the thing about it is it's got to be uniform. That means every bit's got to be similar, same cross section, same density. So what a UDL in this case means is that we've got 20 kilonewtons per meter. So for a 2 meter length, to find the total force, we'd just multiply that by the length. So the force for a UDL, total force is force equals UDL times distance, so that equals 20 kilonewtons times per meter times, well, it's 2 meters long, 2 meters. So the UDL in this case creates a 40 kilonewtons of force. And if we're dealing with it for working out the support forces, we can say that because it's a UDL, we can say that's working at halfway. We can't do that in the full bending diagram, moment diagram, but to find these two support forces, we can. We can model this as a single point at a moment. So let's do that. Let's actually model this as a single point just to find the support forces. So we've got force left, force right. To find out force right, remember sum of forces equals 0. Sum of moments equals 0. So basically what we can say is this is a 40 kilonewton force at 1 litre. So for force right at 4 meters plus 40 kilonewtons, sorry, let's not worry about the units at the moment, at 1 meter plus 60 at 3 meters equals 0. So force 4 times force right is equal plus 40 plus 180 equals 0. So 4 times force right equals negative 220. That's just these two added together and shifted across. So force right equals negative 220 over 4 equals negative 55. What that says is that this force is 55 kilonewtons acting up. What about over on here? Remember to find force left. Sum of forces equals 0. So basically, if I'm saying that, we've got 40 kilonewtons plus 60 kilonewtons minus 55 plus FL equals 0. So that's equal to 45 plus FL equals 0. Just adding these up, 40, 100 minus 55, 40. FL equals negative 45. So this side is going to be 45 acting up, this side's going to be 55 acting up. Let's just check if that's right. So remember, this is 40 acting down. So plus 60, there's 100 in total acting down. There's 45 plus 55 acting up, so 100 in total acting up. But, okay, so we can model this. So let's actually carry this on. Let's do the bending moment diagram. Let's do the shear force of the free body diagram, first of all. So the free body diagram has got, we'll put our UDL on here because that's important. So basically here we've got 45 up, here we've got 60 down, 45, 60. Here we've got 55 up. And over here, got down as 20 kilonewtons per metre. Okay, and this is, well, sorry, I was meant to put that there, wasn't I? Sorry, 55. So that way, this is going to be 2, 3, 4. So now we do our construction lines just to keep everything in one place. Okay, and what's happening here? Okay, well, here's our zero line. So the very first thing that happens, let's put our line off here. The very first thing that happens when we're drawing this diagram is we start at the left and it goes up 45. It goes straight up 45. Then gradually it drops 40. Remember, it's 20 kilonewtons per metre, and we worked out that the total for that was going to be 40. So that drops 40, so 45 minus 40 is 5. And that's going to, because this is a UDL, this occurs slowly. This is a point, so that occurs at once. This is a point load, so that goes up suddenly, but because this is a UDL, it goes down slowly. And then there's no more forces, so that goes along at 5. And then it drops suddenly, 60, so we go from 5 down to negative 55. Go along, and then we go up 55. And for a simply supported load, you start at 0, you end at 0, life is good. Now we're going to come to the bending moment diagram. So this is the free body diagram. This is just the beam with all the forces acting on it. This is the shear force diagram. And this is the bending moment diagram. This lets us work out what our maximum bending force is. So, but because this is a UDL, okay, let's work out the points, values here, 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 and here. So we start at 0. Because remember, if it's cantilever, it might not be 0, but this is free. This is free support at each end. We then work out we've got 3 areas. 1, 2, 3. This one is a trapezium. So there's 2 ways that we can do this. We can break it up into a triangle, or we can go area 1 is equal to height 1 plus height 2 over 2. So we take the average height times it by the base, and that will give us the area of that. So that's equal to 45 plus 5 over 2. So 50 divided by 2 gives us the average of 25 times 2. So this is actually cancelled out, so we end up with 50. So we end up, we've started 0 and we end up at 50 Newton meters. So that's 50. But the problem is this, if this was a horizontal line, it gives a straight line here, but this is not horizontal. What that actually does is means it's going to be curved. It's going to be curved that way, or it's going to be curved that way. If you're worried, just take the midpoint, work it out at the midpoint, and that tells us that this one is going to be shaped like this. It's going to be curved. Then once we're at 50, we add on area 2. Area 2 is equal to, well, we're at 5 kilonewtons times 1, and the distance is 1 metre. 5 kilonewtons times 1 metre equals 5. So we're going to go up to 55 kilonewton meters. And area 3 is equal to, because again this is a rectangle, is equal to negative 55. Remember, it's under the line. Times 1 equals negative 55 kilonewton meters. So it's going to go back down to 0. And what this means is if we want to draw whether it's bending or sagging, it's basically sagging. This is the moment of the maximum bending moment, and so in fact, it's the maximum bending moment, and in fact that is when your beam is going to be under the maximum stress. So the way that we do a UDL is we work out the total weight and use that halfway along when we're working out the support forces. Then we have to draw an angled line on the shear force diagram, and then we're going to end up with a curved line on the bending moment diagram. And as I said, if you're not sure whether it curves this way or this way, work out the value halfway along, and that'll tell you whether it's arcs that way or that way. Okay, so good luck on bending moments. This is probably more than you needed. Remember, this method of the graphical stuff is really good as a general purpose, simple way of visualizing stuff and on simple problems. On harder problems, you'll have to use more mathematical methods, but this is a good way of understanding what's happening. Basically, we just integrate along this bending moment diagram. It's just integrating along here.